In this lesson, we're going to learn about a new kind of block, the switch block. When we started out with programming, we stepped through blocks on the sequence beam one at a time, visiting each block exactly once. Then we learned about using loops in our programs, where sometimes the same block may be visited hundreds or thousands of times. But so far, with all of the programs we've written, whether they contain loops or sensor weights or just regular blocks, all of our blocks have laid centered on that main sequence beam. And as long as we leave the loops in the weight blocks, we expect that all the blocks will be executed at least once. But switch blocks act like a fork in the road. You choose which path to take based on the current situation. For example, the switch block depicted here is dependent on the state of the light sensor. If, when we arrive at this switch block, the sensor detects a lot of light in the room, the NXT will execute only those blocks that are on the top path and ignore any blocks on the bottom. But if the room is dark, then the NXT will execute only those blocks that are on the bottom path and ignore any blocks on the top. So let's write a program that uses a switch block. For this program, we will switch based on the touch sensor. So why don't we start out with a sound? I'm going to scroll up to the sounds that start with exclamation points. Those are kind of sounds as opposed to speech words. And maybe we'll use the fanfare. That's kind of good. Here we go. Okay, and then I'm going to grab a switch block and stuff that on the sequence beam. And this is already set to be a switch touch. You can see that if I click on the type of sensor, we can choose all sorts of different sensors, our sonar, our light sensor, but we're going to stick with touch. And our action is going to be whether the button is pressed. So if the button is pressed, we take this top route. If the button is not pressed, we're going to take the bottom route. So what I'm going to do, let's grab a sound, and if the button is pressed, all we're going to do is play a tone. Let's play kind of a high tone. There we go. And maybe we'll play it for a full second. And if the button isn't pressed, I kind of want to show you that I can put lots of stuff in on one end of the one side of the switch and not the other. So we've only got one thing on top, but let's put a few things on the bottom. You could always do it the other way too. Let's display a picture. Maybe we'll do the lightning cloud. That's kind of nice. There we go, lightning cloud. And then let's get really exciting. Let's put some words under the lightning cloud. So let me stuff it in there. And we don't want an image anymore. We want text. And I want the text to say boom. Maybe an exclamation point. And let's put it kind of center. Actually, I'm going to do that on line 8 at the very bottom. And the last thing I need to remember is to tell it not to clear the display. So it'll draw the lightning bolt and then it won't clear the display. It'll leave the lightning bolt up there when it says boom. And then finally, why don't we play a sound? And this time we'll play a lower note. So we'll play a tone again. We'll set it to have a duration of 1 second, but this time we're going to play a lower note. There we go. And then once we're out of the switch, just to make it clear we're out, why don't we say goodbye?
Goodbye.
Okay, so let's download this. Okay, so let's test this out. Let's try it with the button pressed the first time, so it should take the upper route. So we expect just the high note and nothing else. There you go. So we started and we played the fanfare before the switch. We had just the high note, nothing else inside the switch, and then we said goodbye. Let's try it again. This time I'm going to leave the button unpressed. So now we expect a little bit more. We expect the lightning plus the word boom and the lower note when we get into the switch. Let's see. Let's trace this program to make sure we understand exactly what's going on. When we start the program, we go to the first block and the NXT plays the fanfare sound. As soon as the music ends, the NXT asks the touch sensor what its current state is. Let's pretend that the button on the touch sensor happens to be pressed in. So we're going to take the top path through the switch. We play the high note, and then we're done the switch. The NXT says goodbye, and we clean up. Let's trace that same code again, but this time we'll see what happens if the button isn't pressed. We begin again with the fanfare sound, but this time when we check the touch sensor, we discover that the button isn't pressed, so we take the lower path. First we draw the lightning on the screen, then without clearing the screen, we add the word boom at the bottom. Next, we play the low note and say goodbye, and then we're done with the program. Now let's modify our program a bit. By the way, before we change anything, there's actually two ways to display a switch on the screen in this software. Let me just click on the switch. And if you look on the control panel, the configuration panel, you'll see it display flat view is selected. If I uncheck this box, it shows this other view, and you can kind of click these buttons to show what happens if it's true and what happens if it's false. So there's true and there's false. I really prefer the flat view where you kind of get to see everything, and that's the default. I think the reason they offer two views is because when you start putting switches inside of switches or switches inside of loops, you can do all that if you want, your screen gets pretty full, but I still prefer this flat view. Okay, let's try putting this switch inside of a loop. So let's grab a loop and stick it right there. And let's make this loop run on time. Let's make it be a 10-second loop. Okay? And what I want to do is I want to grab the switch and everything in it, and I'm going to drop it inside the loop. There we go. Okay, let me close this robot educator out so you can see everything. Okay, so what are we doing? We play the fanfare, right? And then we're going to go into our loop, and for 10 seconds we'll keep checking the switch, playing the note, or checking the switch and following this bottom one, and then going round again. Okay, and then after the 10 seconds are up, we'll play our goodbye. So let's download this. Okay, so let's see what happens. Remember, it's going to loop for 10 seconds, so it's going to keep doing this. Huh. Well, that was weird. It seemed to start out working at first, but towards the end, the button presses didn't seem to be doing anything. Let's trace our program and see if we can figure out what's going on. We start the program and play the fanfare sound. And when we arrive at the loop, it says, "Welcome, come in." Since this is a loop based on time, the NXT will keep track of the seconds elapsed. This will also help us to understand what's going on. Let's suppose that when we arrive at the switch, the button is pressed. So we take the top path and play the high note. Now, that high note is programmed to last for a full second. Suppose that after half a second, we take our finger off the button. The note's not going to change right now, right? Because we told it to play a high note for a full second, and it's not done yet. Suppose after another quarter of a second, we put our finger back on the button again. The high note still isn't done playing. After the note's done, we check whether the loop is done. In this case, since we set the loop time to 10 seconds, we check whether at least 10 seconds has elapsed. Nope, only 1 second, so the loop tells us to do it again. Now, you might think that since we removed our finger from the button for a moment, that now we should play the low note. But the NXT just follows the instructions in the program, and the program tells it to check the touch sensor and see what it's doing right now. And right now, that button is pressed. So we take the high path again. And another second passes while we play the high note. And then we're at the end of the loop again, ready to check whether 10 seconds have elapsed. We're not actually done tracing the program, but I hope you get the idea. We only check the state of the touch sensor when we arrive at the switch. So the first few times I tried it, it was working great, but when I didn't time the button presses to correspond with the switch, it didn't work. So if we want this program to react to a button press more quickly, we really need to make the stuff that happens inside the switch happen more quickly. So let's take this tone that we're playing, and instead of doing it for 1 second, let's play it for 0.1 seconds. That's pretty fast. These two displays happen almost infinitely quickly, so it's really just this tone on the bottom that again will make it go for 0.1 seconds. And let's download. Okay, so now let's see what happens. And what I expect is that the NXT is going to react much more quickly to my button presses because each musical tone only lasts for 1/10 of a second. So let's go. There you go. Now, you notice that that boom lightning was on the screen the whole time. That's just because we never told it to go away. It may look a little weird to you that that lightning picture stayed up there even when we were on the upper part of the switch, but that's actually what we programmed it to do. Let's change that. So if you look at this, we tell it to put the picture of lightning and then the words boom up, and we never tell it to take them down. And of course, the NXT is not going to do that till it gets to the very end of the program when it cleans up, unless we tell it to. So let's explicitly tell it to. Whenever we play this high note up here, let's add a display block. And this is a display block we haven't actually seen before. Instead of an image or text or drawing, we're just going to select reset. And reset means clean up, reset the display. So let's see what this does now. I'll download. Okay, so let's see what happens. I expect that when I push the button, the lightning will go away and we'll have the high note. And when I release the button, the lightning will be there with the boom and we'll have the low note. Let's see. So there's our lightning. Ah, look, it went back. Worked great.